Okay, so what we're going to show now is alternate interior angles theorem. I'm going to illustrate what we have. So what do we have in this case? Okay, so in this time, we have that this line we know is parallel to this line, and we want to show that this angle here is congruent to that angle there. Now, how do we do this? We need a few things. We need two things in our hands, okay? The first thing we need is vertical angles theorem, right? Okay, that's what we need to understand. If you don't understand vertical angles theorem, you cannot understand this proof. Okay, that's one thing we need. And then the other thing we need is corresponding angles axiom. Okay, these are the two things that we have in our hands, okay? We proved this, so we have that. The axiom, we don't need to prove. We just take it as true. So let's understand first vertical angles theorem. Vertical angles theorem says that if angles are vertical, then they are congruent. So then that means right away, 2 is the same as 4. 1 is the same as 3, right? So 2 is the same as 4 because of the vertical angles theorem. 1 is the same as 3 because of vertical angles theorem. 5 is the same as 7 because of vertical angles theorem. And then 6 is the same as 8 because of vertical angles theorem. Okay? All vertical angles are congruent. That's vertical angles theorem. Now, the next thing we have in our hand that we need to understand is corresponding angles axiom. So now what does this say? This says that corresponding angles are congruent. And with even just this diagram and just illustrating these two ideas, we pretty much have proven the theorem, because what's corresponding? What does corresponding angles axiom say? It says if the lines are parallel. Well, these lines are parallel, so check in that. So let's write actually what it says. If L is parallel to M, then corresponding angles are congruent. Okay, that's a real quick way to write the axiom. Okay, so these two lines are parallel. Then I know all the corresponding angles are congruent. So what's a corresponding angle? You got to think of these 4 angles and then these 4 angles. And you got to relate them by what I'm about to say. We should see that among these 4 angles, 1 is in the top left position. So then that means that it corresponds with the angle in the bottom 5 that's in the top left. So 1 and 5, because 1 is in the top left among these 4, and 5 is in the top left among these 4. So the lines are parallel. That immediately means that 1, all the corresponding angles are congruent, but in particular then 1 is congruent to 5. So then 1, you know, is the same as 5. Similarly, 2 corresponds with 6. So then 2 is the same as 6. But 2 is the same as 4. So then what do you have? You have that 6 is the same as 4, and we've proven the theorem and we're done. Again, so since we have, right, so what's corresponding? 2 is corresponding with 6 because they're both in the top right positions. The lines are parallel, so we know that since the lines are parallel, that all the corresponding angles are congruent. So 2 is the same as 6. So instead of putting 4 ticks here, I know that it's a single tick and that 2 matches with 6. Then I know 2 is the same as 4 from vertical angles theorem. So then this must mean, look, 6 is the same as 2. 2 is the same as 4. Therefore, 6 is the same as 4, and you're done. That's the theory. Now let's write it. Okay, we'll go through it again. Okay. So what is the theory? What's the writing? What should we write? We should say, let's say, and it doesn't really matter where you start. There's many ways to prove this. Angle 2 is congruent to angle 6 by what? Corresponding angles axiom. Look, 2 is the same as 6 because they're both in the top right position and the lines are parallel, right? The lines are parallel, corresponding angles are congruent. So by corresponding angles axiom. Then you can say that 2 is the same as 4 By what? Well, why is 2 the same as 4? Because they're vertical. So, by vertical angles theorem. And then you could say it like this. 4 is the same as 2. 2 is the same as 6. Therefore, 4 is the same as 6 by what's called transitivity, which is just to say A is the same as B, and then B is the same as C. Then you can go from A to C. You can right? This is true and this is true. You can go from A to B, then you can go from B to C, then you can go from A to C. This is called transitivity. And that's what we did here. I went from 4 to 2, then from 2 to 6. Therefore, I could go from 4 to 6 by transitivity. And this is it. You're done. You showed your last statement is the conclusion. I started off with this. I ended with this. That's the whole idea. We know that we could use corresponding angles axiom because these two lines are parallel. Okay?